Dear students, welcome to the online class. I am Dr. SSC Hiramat. In this video, you are going to study about the wet adsorption isotherm. Brunner, Emmett, and Teller have derived the equation for multilayer adsorption of gas molecules on solid surface. Based on the above postulates, accordingly, formation of first layer is represented as A gas plus S forms AS, and the equilibrium is K1, and K1 equal to concentration of AS divided by concentration of A and concentration of S, which is equal to pi 1 divided by pi V into P, where A is adsorbate, A is equal to adsorbate, S is surface sites, AS first layer, pi V is the fraction of sites which are free, and pi 1 is the fraction of total sites used to form first layer. K1 is equilibrium constant, and concentration A is expressed as pressure P. For successive levers, the successive levers the successive layers may be written as A gas plus S forms AS, A to S, and this is with equilibrium constant K2, and K2 equal to concentration of A to S divided by concentration of A into concentration of AS. This is equal to pi 2 divided by pi 1 into P. Suppose this is equation 1 and this is equation 2. Another layer may be formed, that is A gas plus A to S gives A3S with equilibrium constant K3, then K3 equal to A3S divided by A into A to S, which is equal to pi 3 divided by pi 2 into P. Suppose this is equation 3. For nth layer, AS plus A n minus is forms ANS with equilibrium constant Kn. Then this is K3 is equal to pi 1 divided by pi n minus 1 into P. Suppose this is equation 4. Here the K value K1 is different from other K's, K2, K3, K4, Kn, as it is assumed that K1, K2 is equal to K3 equal to K4 equal to Kn, which is equal to K. Suppose this is equation 5. From equation 2 and 3, you substitute the value of Kp, that is pi 2 is equal to K2 into pi 1 P, pi 3 equal to K3 into pi 2 P, which is equal to you substitute the value of, that is K2, K3 all are equal, then K2 into P, K3 into P, then you substitute pi 2 from this. Pi 2 equal to pi 2 into kp square. That is pi 3 equal to pi 1 kp square. You substitute the value of pi 2 from this equation. Then in general, pi I equal to pi 1 into kp raised to I minus 1. Here if it is pi 3, kp raised to 2. Okay, similarly here pi 1 means pi I equal to pi 1 into kp raised to I minus 1. That is 1 less than this I. Suppose this is equation 6. Now there is a small correction in equation 4. This is n minus 1. This is the nth equation, n minus 1 gives an into s, and this is kn and pi n divided by pi n minus 1 p. This is a small correction in equation 4. Now the total surface area of adsorbent is equal to the sum of vacant sites and surface areas of successive layers. The total area is taken as equal to 1. Then 1 equal to pi v plus pi 1 plus pi 2 and up to pi I, which is equal to pi v plus summation of pi I, from the equation 6 1 equal to pi v plus pi I equal to summation of pi 1 into kp raised to I minus 1. That is I equal to 1 to I. That is 1 equal to pi v plus, you may take this pi 1 common and summation of kp raised to I minus 1. By taking kp equal to x, we may write the expanded form of equation 7. Suppose this is equation 7, has 1 equal to pi v plus pi 1 as it is. Then you take I equal to 1, 1 minus 1 equal to 0, and kp raised to 0 equal to 1. This is 1 plus I equal to 2, 2 minus 1 equal to 1, kp raised to 1 means x raised to 1 x. Similarly, x square, x raised to 3, then x raised to I minus 1, I minus 1. Here, this expansion may be taken as equal to, that is 1 equal to pi v plus pi 1, and this may be taken as equal to 1 divided by 1 minus x, 1 divided by 1 minus x. Suppose this is equation 8. Equation 8. From equation 1, where we have taken k1 is different, that is k1 is equal to pi 1 divided by pi v into p, or pi 1 equal to k1 p into pi v, or pi v equal to pi 1 divided by kp, k1p. Here it may be taken as pi 1 divided by some other constant, that is c into x. Here instead of taking the kp equal to x, some other constant is also used. Here k1p is taken as equal to cx. Suppose this is equation 9. Now from equation 9 and 8, from equation 8 and 9, that is 1 equal to pi v equal to pi 1 divided by cx plus pi 1 into bracket 1 minus 1 divided by 1 minus x. It may be taken as equal to 1 is equal to pi 1 is common, this is equal to 1 divided by cx plus 1 divided by 1 minus x, which is equal to pi 1. You may take LCM, cx into 1 minus x is equal to 1, that is cx plus 1 minus x. Now we may take this 1 equal to pi 1 into bracket, you take x common, pi 1 as it is, then 1 minus x is taken as common, then 1 minus c minus 1, this is c minus 1. Here suppose 1 is kept as it is, then x is taken common, here. Suppose this is x, is equal to 1 minus x into c minus 1 divided by Cx into 1 minus x. Suppose this is equation 10. This is 1 plus. Okay, when 1 is taken common and x is taken common, this becomes c minus 1. Suppose this is equation 11. Now, the number of molecules adsorbed is proportional to the area of surface adsorbed and proportionality constant may be taken as equal to Cs if n is the total number of molecules adsorbed, then n equal to Cs proportionality constant, then area of first layer and area of second layer multiplied by 2, as there are 2 layers. Similarly, third layer multiplied by 3 and so on, nth layer multiplied by pi n. Okay, pi n, which is equal to Cs into bracket summation of pi I into pi I, summation of I into pi I. From equation from equation 6, pi I is equal to pi 1 kp raised to I minus 1, that is equal to pi 1 x raised to I minus 1, x raised to I minus 1. Suppose this is equation 12. This is equation 12. So this is equation 13. Then equation 13 12 becomes n equal to Cs into bracket summation of pi 1 I x raised to I minus 1, which is Cs into pi 1, and we may take when I equal to 1, x is I equal to 1, this becomes 0, x raised to 0 means 1. Then when I equal to 1, when I equal to 2, that becomes 2x, 3x square, 4x cube, and so on and so on. Then we may write this is equal to Cs into pi 1. Here this is the expansion of, this series is the expansion of 1 minus x square. 1 minus x square. Thus we may write n equal to Cs into pi 1 into 1 minus x square. Suppose this is equation 14. Equation 14. Now Cs may be taken as equal to the number of molecules present in first layer. That is equal to Nm. Then equation 14 becomes N equal to Nm into pi 1 divided by 1 minus x square. So this is equation 15. By substituting the value of pi 1 from equation 11. Equation 11 is this equation. We get n equal to Nm and pi 1 equal to Cx into bracket 1 minus x divided by 1 plus x into bracket c minus 1 into divided by 1 minus x square. 1 minus x square, and this 1 minus x square, 2 square, and 1 minus x gets cancelled. That is n equal to Nm into Cx divided by 1 plus x into bracket c minus 1 into bracket 1 minus x. Suppose this is equation 12. This is equation 16. Here the number of moles of molecules adsorbed is directly proportional to the volume of gas adsorbed. Then by taking Vt as total volume of the gas containing n molecules and Vm volume. Vm is the volume of monolayer gas containing Nm molecules. Then Nm by N divided by Nm is equal to Vt divided by Vm. By substituting this, in equation 16, we get Vt is equal to Vm C into X divided by 1 plus X into bracket C minus 1 square bracket into 1 minus X. Suppose this is equation 17. Initially we have assumed that X equal to Kp and K equal to 1 divided by P naught. Then X equal to P divided by P naught. By substituting X equal to P divided by P naught in equation 17, we get Vt, this Vt is equal to Vm into C into P divided by P naught divided by 1 plus P divided by P naught into bracket C minus 1 into 1 minus P divided by P naught. Suppose this is equation 17 or 18. That is Vt is equal to Vmc into P divided by 1 plus P divided by P naught into bracket C minus 1 square bracket into P naught minus P. Here this P naught, here P naught minus P divided by P naught, then this P naught get cancelled, then you are going to get equation 19. That is, on rearranging equation 19, we get Vt as it is divided by P. You take this P in the denominator and you take this P naught minus P in the numerator. numerator. This is equal to Vm C divided by 1 plus P divided by P naught into C minus 1. C minus 1. Suppose this is equation 20. On inverting equation 20, we get inversion of this means P divided by Vt into P naught minus P is equal to this 1 divided by Vm C, one term, plus C minus 1 divided by Vm C into this becomes numerator, that is P divided by P naught. P divided by P naught. Suppose this is equation 21. Equation 21. That is P divided by Vt, P naught minus P, 1 divided by Vmc, Vm into C, C minus 1, C minus 1 is the numerator, divided by this Vmc into P naught, P divided by P naught 21. Okay. Then equation 21 is the bed adsorption isotherm.